of the time, it's been sine and cosine graphs on the regents, and they will absolutely come up at least once, if not more than once. Tangent graphs are kind of hit or miss. I've seen maybe one question on a tangent graph. We'll still do it. I'll still expose it to you, but most everything's going to come back to sine and cosine. Okay. Before we jump into the graph of it, I'm going to remind you of the values as you go around a sine circle. Now, keep in mind, most of the time with trig graphs, your x-axis is in radians, not degrees. Okay? So at 0 radians, the sine of 0 is 0, and then the sine of 30 degrees slash pi over 6 is 1/2, and then root 2 over 2, root 3 over 2, and root 4 over 2, which is 1. And that's your first quadrant where all of your sine values are positive. All. In the second quadrant, they're also all positive for sine, but these numbers now just start to decline. So we went from 0 and worked our way up to 1, and now we're starting at 1 and we're going to work our way back down to 0. So 1, root 3 over 2, root 2 over 2, 1/2, and 0. Okay? We're now, as we go through the third quadrant where sines are negative, all students take calculus, so tangents are positive, but sines are negative. We're going to continue to decrease. We were decreasing from 1 down to 0. We're going to continue to decrease from 0 down to -1 and go through these numbers in the negative direction. So -1/2, negative root 2 over 2, negative root 3 over 2, and -1. And in the fourth quadrant, where only cosine is positive, our sines will be negative again, but they're making their way back to an even 0, right? So negative root 3 over 2, negative root 2 over 2, negative root 1 over 2, which is -1/2, back to 0. Okie doke. So, on my table of values, I did not include a lot of this stuff in between. I have 0, so when x is 0, the sine of 0 is 0. The next point I put on my table of values was when x is pi over 2, which is here, the sine of pi over 2 is 1. I skipped a lot of what was in between because like root 2 over 2 and root 3 over 2 are not very nice numbers, right? I could have put pi over 6.5 in there, but it's not like perfectly halfway in between, so I didn't do it. Pi over 4 is perfectly halfway in between, so that might be nice from like a symmetry perspective. So if you wanted to, let's throw a pi over 4 in there. And the sine of pi over 4 is root 2 over 2, which, just to get a feel for that decimal, is 0.7-ish. So if you wanted to throw that in there, good. And then I don't include another point until pi, which the sine of pi is 0. Again, if I wanted to, 3 pi over 4 would be a nice halfway point. That's halfway between pi over 2 and pi. And that would also be a 0.7. So that brings us through the first two quadrants. Are we good there? Okay. Let's go and plot those 5 points, I guess, now, since I added some in there. So x is your angle. We have a 0 radian angle with a 0 sine value. So we'll just do 0, 0. I'm going to scale. My y-axis is not scaled for me right now. I'm just going to, for the sake of spreading it out a little bit, I'm going to skip a line and do +1 and skip a line and do -1. Because if you go around your unit circle, the highest value sine ever gets to is 1, and the lowest ever gets to is -1. So I don't really need all that space. So I'll spread it out. So when I go to pi over 4, which is halfway between 0 and pi over 2, I'm going to approximately 0.7. And then pi over 2 is paired with 1. And then 3 pi over 4 is 0.7 again. And pi pairs with 0. So far, here's what my graph looks like. And there are a couple things I want to point out about that. Your first quadrant, and I'll give you a second to catch up so we're all looking at the board. Your first quadrant is from here to here. So it makes sense, I'm going to put Q1 there. It makes sense that these are positive values above the x-axis, right? Not only is it positive and above the x-axis, but is it increasing or decreasing in the first quadrant? Increasing. If you think about your unit circle values, that makes sense. It's increasing from 0 to 1. Then what does it do in the second quadrant? Starts decreasing, but it's still positive numbers, right? So we're still in quadrant 2, we're still above the x-axis because we still have positive sign values, but it's decreasing back down to 0. Follow? Okay? Then when we get to quadrant 3, our values are negative, and are these numbers increasing or decreasing? Decreasing. You're starting at 0 and you're getting deeper into the negatives. That's decreasing. So you're negative and you're decreasing. So this will go into the negatives and it will continue going down for a while. So 3 pi over 2 has a coordinate of -1. So if you plot that, 3 pi over 2, comma -1, and just you'll get more and more used to the curvature of these. I'm not going to do that intermediate point on this one. I'm just going to kind of smooth it out, knowing that -1 is the absolute lowest I ever get, right? And then 2 pi, by the time I get back here, I'm still in the negatives in the fourth quadrant, but I'm increasing back up to 0 because 2 pi pairs with 0. So in Q4, I'm still in the negatives, I'm still underneath the x-axis, but I start to increase through quadrant 4. So understanding and seeing those parallels between the unit circle values and how these behave, positive and negative and increasing and decreasing, does match up to this section of the sine graph, which is known as the parent graph. Okay? Now, because in our unit circle, I mean, we just went around 0, and then we went all the way around, and we looked at all the angles through 2 pi, I can keep going, right? And when I keep going, this cycle is just the full cycle that I just did is just going to repeat itself. So I could keep going, and I would get an additional cycle. I'm going to run out of room here, but I would get an additional cycle, and this would just continue infinitely. But I really want you to boldface this first rotation around the unit circle, because that's our parent graph. That is the basic sine curve shape that we will be working from. Okay? And likewise, if you go in the negative direction, right? We started at a 0-degree angle or 0 radian angle. We went in the positive direction. So on our graph down here, we were moving to the right. But you could just as easily go back into the negative direction, right? When I go back into the negative direction, what's happening with these values, the sine values? Are they increasing or decreasing? They're decreasing. This would continue to decrease back to -1 when you hit negative pi over 2. And then if you kept going backwards all the way to negative pi, the coordinate is 0. Jack, open your eyes. And then you'd keep kind of going backwards past negative pi in the negative direction. You'd get to negative 3 pi over 2, which would be at a 1. And then keep going backwards all the way to negative 2 pi, so a full circle in the negative direction, you'd be back to 0. But again, start of your cycle to the end of your cycle, this is really the parent portion. This is the portion that we will eventually start shifting. Shifting left, shifting right, stretching vertically, shifting up, shifting down, and so on. But as far as the features of the parent graph, and knowing that this continues forever, the domain is from negative infinity to positive infinity. You can take the sign of anything. So negative infinity to positive infinity. The range, however, does have a lowest to a highest. Jack B, what's the lowest and then what's the highest value of the range? It never reaches negative 2. Negative 1, 2, positive 1. Does it actually reach negative 1? Meaning, am I going to use a bracket or a parenthesis? Bracket. It does reach negative 1 and it does reach positive 1. Good. The interval notation for where this graph is positive, and we'll just talk about this portion here, that main section. It is positive from 0 to pi. Does everyone see that? Because that's where it's above the x-axis. So from 0 to pi, and then it's negative from pi to 2 pi. Now, do these deserve parentheses or brackets? At 0, is it actually above the x-axis? No. At pi, is it actually above the x-axis? No. So it's not actually below the x-axis either there, nor is it at 2 pi. So those both have parentheses. Good? Any questions so far? Okay, the period. There's your one main cycle. How long is that? This is extremely important. How long is that? Starts at 0, ends at 2 pi. How long? 2 pi. The period is 2 pi. The sine cycle repeats itself every 2 pi radians, every 360 degrees, which should make complete sense because think about your unit circle. These values start to repeat themselves once you get a full circle in, right? And then they just go through again and again. So your period is 2 pi. Your midline of your parent graph is right down the middle, y equals 0. Your amplitude, we don't have any vertical stretches or compressions here in a parent graph, so your amplitude is just 1. And then even, odd, or neither. This talks about symmetry. Let's review. Even is symmetrical to the y-axis. Odd is symmetrical to the origin. And neither is neither symmetry. So is this symmetrical to the y-axis? If I take this and fold it over the y-axis, will it map onto itself? No. If I take this and fold it over this line, it'll be here. Right? If this was a line of symmetry and I took this and flipped it over, this here would look like this, which is not on itself. Not symmetrical to the y-axis. The y-axis here is not a line of symmetry. Is it symmetrical to the origin? meaning right side up versus upside down. So if I flip this upside down, does it look the same? Yes, it starts at 0, it increases, decreases, then decreases and increases. So it is symmetrical to the origin, which means it is an odd function. Okie doke. And then on the fourth one here at the bottom, the fourth section gets us starting to think about transformations again with these types of functions. So you always work from the inside out. So there is, it used to be the sine of x. Now it's the sine of 2 times, and then this x minus pi over 2. So what does this 2 do? What does that multiplier of 2 do? Horizontal or vertical? No. The 2 is in here, so it's within the function. Anything within the function is horizontal. Yes? Anything in front of the sign or after the x, after you take the sign of the number, is vertical. So this is within the function. That's a horizontal, it's not a stretch because horizontal things are backwards. It's a compression. Horizontal compression by a half. Now, when you horizontally compress a graph, a trig graph, so I'm going to smush it in horizontally, is that going to affect the period, midline, or amplitude? The period, right? If I horizontally compress this, it's going to affect the period, which used to be 2 pi, and then I smushed it in, so it's going to be a little bit smaller than that. Yes? This right here is still within the function. Here's me, this is all within the function. This is all what I'm taking the sine of. So this x minus pi over 2 is also horizontal. What's the transformation? Is it a dilation, shift, or reflection? Shift. Which direction? Right, pi over 2. So what that would look like is, rather than starting at 0, this main image would just be sliding over and actually starting at pi over 2. And would continue on from there. Okay, then we go to the outside. The stuff that's in front is vertical. So this is a vertical what? Stretch by 2. Now what will that affect? The period, midline, or amplitude? Amplitude. If I stretch away from the x-axis, that's going to affect the amplitude or the height of the wave. And then this last thing, this plus 1, shifts up 1. When you take a graph and just shift it up 1, what does that affect? The period, the midline, or the amplitude? The midline, right? The height of the wave won't change if you just shift it up. So the amplitude's the same. But the midline will have just moved up. The middle of the wave will just be in the new location. Good? Okay. On the back, very similar. We won't go through it in as much detail because it's the same thing again, but the cosine graph. We are still going to start, though, with remembering our values. The cosine of 0 is what? 1. And it decreases, right, down to 0. Yes? So from there, it still decreases down to -1, and then it will start to increase back to 0, and then eventually back to 1. So if I just, cosine of 0 is 1, cosine of pi over 2 is 0, cosine of pi is -1, 3 pi over 2 is 0, and 2 pi is back to 1. If I just use those 5 critical values and plot it, and again, I'm going to make this 1 and this -1. So plot the point 0, 1. the point pi over 2, 0. Plot the point pi negative 1. 3 pi over 2, 0. And 2 pi 1. And once you get around a full circle, that will just continue to repeat itself. That's the parent graph for a cosine. Do you see how a cosine starts at an extrema, a max or a min, versus the sine graph starts on the midline? That's huge. Sine graphs start on the midline. Cosine graphs start at either a max or a min. The parent starts at a max. But do you see again through quadrant 1 where cosine is positive, because all things are positive? It's above the x-axis, but it is decreasing from 1 down to 0. Yes? In the second and third quadrants, it is negative. Cosine is negative. That's why here in quadrant 2 we are underneath the x-axis, and in quadrant 3 we are still underneath the x-axis and negative. It's just from 0 to negative 1 we're continuing to decrease, so we're still going down. And then from negative 1 to 0, even though we're still negative, we're starting to increase. And then cosine is positive in quadrant 4. That's because you're increasing from 0 to 1, and those are positive numbers. So you see it's still increasing and in the positive section. Yes? So if I were to continue this backwards, we'd get there. By negative pi, we'd be at negative 1. By negative 3 pi over 2, we'd be back to 0. And by negative 2 pi, we'd be back to 1. But this section, again, from 0 to 2 pi, that's the main cycle we'll be working from. And then once we get that stretched, compressed, shift, whatever has to happen to it, then we'll just continue the rest of the graph in the same pattern. But you really focus on just one cycle in getting that location down and then extending it as necessary. So if we go back to these main features, our domain is still negative infinity to infinity. Our range is still negative 1 to 1. We're positive from 0 to pi over 2. And that does include 0, by the way. It does not include pi over 2. And we're positive again from 3 pi over 2 to 2 pi. And again, I'm just running through the main cycle of this. We're negative from pi over 2 to 3 pi over 2, this whole little U-shaped section. And those are both with parentheses because at the endpoints are actually 0. Oh, and what's the length of my cycle? What's the period of this cycle? Still 2 pi. Very good. Midline, still 0. Y equals 0. Give me an equation of a line for that. Amplitude is still 1. And how about even, odd, or neither? Is it symmetrical to the y-axis? If I flip this over the y-axis, does it land on itself? Yes, even. And the last thing down here is describing these transformations. So here, your parent graph is cosine x. Here's our new thing. Here's all of the inners. This is what we're taking the cosine of. So anything in here is horizontal, starting with the 1/2. That's a horizontal what? Stretch by 2. Good. That will lengthen the period. Period starts off at 2 pi. It's going to stretch it out to 4 pi. It's going to double it. So your full cycle wouldn't actually complete itself till you got to 4 pi. How about this plus 3? Horizontal what? Shift, left, 3. We're going to start only in the trig world. We refer to that as a phase shift, which we'll talk more about. And then vertically, this out in front does what? Vertical reflect over the x-axis. Very good. And the -2 is a vertical shift down 2. Okay, so those are the basics. Jason, take one pepper out and just let it snake through. Because I just want to show you quickly while that homework's coming around, and you don't have to do this, you can pack up, but just watch. Watch, but don't talk. If you are graphing trig on your calculator, sine of x, for example, you have to be in radians. So when you go to your mode, degree will not work. Has to be radians. What I also suggest is when you set up your window, you start at 0 and go to 2 pi on your x-axis. You can literally type in 2 pi. When I scroll off of it, watch what happens to the 2 pi. It becomes the decimal version, but that's fine. And I also suggest you don't count by ones. Count by pi over 2. And then, hold on, your y min to your y max, I'm just going to do -2 to 2 and watch the graph of your sine curve show up. And you see, because I counted by pi's over 2, it kind of jives with my quadrants better that way. So more on that tomorrow. But your homework.